Hi guys, I am Julius A. Serrano, BSAMT student from University of Perpetual Help School of Aviation. Now this subject is Engine System section 15110. And for this subject, I'll be discussing with you the fundamentals of induction system. Now, the induction system brings in air from the outside, mixes it with fuel, and delivers the fuel and air mixture to the cylinder where combustion happens. This combustion creates the thrust or power from the power plant. Outside air enters in the induction system through an intake port or the front of the engine cowling. This port normally contains an air filter that inhibits the entry of dust and foreign objects. An alternate air comes from the inside in engine cowling, where it bypasses a potential clogged air filter. Some alternate air sources function automatically while others operate manually. Now, there are two types of induction systems are commonly used in small aircraft engines, and that too is carburetor system and fuel injection system. Now let's discuss first the carburetor system. The carburetor mixes fuel and air mixture before this enters the intake manifold for combustion. Carburetors are calibrated at sea level, meaning as you increase in altitude, the air pressure is going to go down while the fuel will remain constant, causing a rich mixture if not fixed. This can cause a foul spark plugs. Fuel distribution is not as accurate as fuel injection. Relatively simple, few moving parts. Large fuel lines hard to clog. And lastly, cheap. They're very cheap. There are two types of carburetor. First is the float type carburetor, and the second one is the pressure type carburetor. The float type carburetor is the most common type of carburetor. In the operation of the float, the carburetor system, the outside air first flows through an air filter, usually located at an air intake in the front part of the engine cowling. This filtered air flows in the carburetor and through a venturi, a narrow throat in the carburetor. When the air flows through the venturi, a low pressure area is created, which forces the fuel to flow through a main fuel jet located at the throat. The fuel and air mixture is then drawn through the intake manifold and into the combustion chamber, where it is ignited. The float type carburetor acquires its name from a float which rests on a fuel within the float chamber. A needle attached to the float opens and closes an opening at the bottom of the carburetor. A float type carburetor is just like the same system with the one that's inside your bowl in the comfort room. The disadvantages of this float type system is it abrupt maneuvers disrupts the float. Fuel must be discharged at low pressure, leading to incomplete vaporization and difficulty discharging fuel into some supercharged systems. Most importantly, it has an icing tendency discussed below. Next, pressure type carburetor. A pressure-type carburetor discharges fuel into the airstream at a pressure well above atmospheric via a fuel pump. This results in better vaporization and permits the discharge of fuel into the airstream on the engine side of the throttle valve. With the discharge nozzle located at this point, the drop in temperature due to fuel vaporization takes place after the air has been passed to the throttle valve and at a point where engine heat tends to offset it. The danger of fuel vaporization icing is practically eliminated. The effects of rapid maneuvers and rough air on the temperature-type carburetor are negligible, since their fuel chambers remain filled under all operating conditions. Now, the mixture control. Carburetors are normally calibrated at sea level pressure where to correct fuel to air mixture ratio is established with the mixture control set in the full reach position. However, as altitude increases, the density of air entering in the carburetor decreases while the density of the fuel remains the same. This creates a progressively richer mixture which can result in engine roughness and an appreciable loss of power. The roughness normally is due to spark plug fouling from excessive carbon buildup on the plugs. Carbon buildup occurs because the rich mixture lowers the temperature inside the cylinder, inhibiting complete combustion of the fuel. This condition may occur during the pre-takeoff run-up, at high elevation airports, and during climbs or cruise flight at high altitudes. To maintain the correct fuel and air mixture, the mixture must be leaned using the mixture control. Leaning the mixture decreases fuel flow, which compensates for the decrease in air density at high altitude. Now let's proceed to the fuel injection system. Fuel injection. Fuel injectors mix the fuel and air immediately. Before entry into each cylinder, it injects directly into each cylinder. In a fuel injection system, the fuel is injected directly into the cylinders or just ahead of the intake valve. The air intake for the fuel injection system is similar to that used in a carburetor system with an alternate air source located within the engine cowling. This source is used if the external air source is obstructed. The alternate air source is usually operated automatically with a backup manual system that can be used if the automatic feature malfunctions. A fuel injection system usually incorporates 6 basic components: an engine-driven fuel pump, a fuel air control unit, fuel manifold or fuel distributor, discharge nozzles, an auxiliary fuel pump, and fuel pressure flow indicators. The auxiliary fuel pump provides fuel under pressure to the fuel air control unit for engine starting and or emergency use. After starting, the engine-driven fuel pump provides fuel under pressure from the fuel tank to the fuel air control unit. This control unit, which essentially replaces the carburetor, meters fuel based on the mixture control setting and sends it to the fuel manifold valve at a rate controlled by the throttle. After reaching the fuel manifold valve, the fuel is distributed to the individual fuel discharge nozzles, the discharge nozzles which are located in each cylinder head. The discharge nozzles which are located inject in the fuel air mixture directly into each cylinder intake port. A fuel injection system is considered to be less susceptible to icing than the carburetor system, but impact icing on the air intake is a possibility in either system. Impact icing occurs when ice forms on the exterior of the aircraft and blocks openings such as the air intake for the injection system. What are the fuel injection advantages? First, reduction in evaporative icing. Second, better fuel flow. Third, faster throttle response. Fourth, precise control of the mixture. Fifth, better fuel distribution. Sixth, and last, easier cold weather starts. Fuel injection disadvantages. First, difficulty in starting a hot engine, vapor locks during ground operation on hot days, problems associated with restarting an engine that quits because of fuel starvation. Conclusion. Carburetors are a rare sight with new aircraft but extremely common on your average flight line. Note that the addition of carburetor heat does impact the engine as the hotter, less dense air is then combined with fuel. Failure to lean will result in a richer than previous mixture. That's all for this video, guys. Thank you so much. I hope you understand and learn something new. God bless and stay safe. Again, Julius A. Serrano, BSAMT from UPH Perpetua.